If you're a builder or EPC right now, you are under intense pressure. Build fast, build compliant and bankable with partners who can actually deliver. And in an electricity supercycle shaped by new sourcing rules, domestic content requirements, and unprecedented project volume, who you build with has never mattered more. Today, we're taking you inside one of the companies the entire industry has its eye on and how they are rethinking the power plant itself by connecting steel, copper, and code into one system. This is an inside look at how Nextpower is responding to this moment and what it means for every team trying to build what's next. To start the conversation off, I want to go straight to the source, the person leading the product evolution at Nextpower. Jake Morin is the Chief Product Officer, and he's been at the center of this shift from a tracker company to a fully integrated platform. Jake, it's good to see you.
Thanks, Nico. Nice to see you this morning. Hope you're having a great day.
Jake, the industry's been talking about this systems thinking for years, but Nextpower is actually doing it. You've gone from a tracker company to a fully integrated platform. What needed to be true in the market, in technology, in your customer relationships for this evolution to take shape?
Yeah, well, I think it's important to have some respect for what's come before us. The first thing that needed to be true was Dan Sugar and Howard Wenger and a bunch of, old guard in the solar industry grinding for decades to get the cost of solar down, right? And what's really enabling this at the core level is that we're now the lowest cost of energy unsubsidized on the globe, right? And what does that enable? Well, it enables the type of R&D investment needed to fully integrate these things, right? Where we can now, in a comfortable way, go in and invest in integrating products across our whole portfolio, and really needed to hit that scale in order to do that, right? That's really enabled by that cost.
When you talk about the connected power plant, what does that look like in practice? How does it show up for developers and EPCs in the field right now?
Let's think about how it looks yesterday, right? Yesterday, the power plant is something that shows up in parts and pieces on your doorstep as an EPC in a dirt field where you have to put it together, right? And you have things that are designed with complex interfaces to make them work together. And there's two engineers in two different offices doing their best to figure out how we're going to interact with the minimal amount of communication possible, right? And what it'll look like in the future is something that's designed from the get-go to actually be one product, right? Right now, what a EPC or a developer is receiving is 20, 30 individual unique products that they have to make into the connected power plant, that they have to turn into a product. And by focusing on the power plant as the product, what that enables us to do is really deliver a holistic solution that's designed to clip together and work together from the get-go. And it's really going to smooth operation for our EPCs, whether that's on the design side, where the design process is integrated into the product, or on the delivery side, where it's showing up from one company in one consistent way and an order that they like, or in the construction phase, where we're going to see increased construction velocity and just an ability to things go together simply, or in the operation phase, when you're getting intelligence and data across that whole product stack and giving you just the information you need to execute, right? That's what it looks like in the future.
We've covered in other interviews with Nextpower employees like Jonathan Eastwood how customer-centric the design iteration process is within your team. You don't really build for customers, you build with them. I'm curious, how does that customer-focused design philosophy shape this concept of the connected power plant around the pain points and requests that you all have been directly informed through this evolution process over the last few months and quarters as you prepare for the Nextpower rollout?
On the product side, we are really thinking about our customers across that whole chain of building a power plant. Our engineers are out in the field talking to installers, right? These are people who never sign a contract, never purchase our product, but they have to use it. They're the ones who have to put it together, right? And so having that deep customer focus where even the smallest amount of detail is critical. And as an example, when we first did our first launch, our first pilot for our new foundations platform, NX Anchor, last year, we were facing some challenges. Any new product is a learning journey. And like, we got an email from a customer and I jumped on a plane to Maine the next day. It was in the middle of winter. I'm standing there in a muddy, snowy field, taking notes on the timing of how long the installation takes and taking notes on, what is it like to insert the pile into the machine and stuff like that. And we take that right back to our lab and we're turning really quickly to address those customer constraints. And I think one of the beauties of having this integrated platform is that it allows us to do that deep level of customer care, that deep level of listening about small tweaks in a really rapid way. We can change the foundation and the tracker together. We can change the eBOS and the tracker together really quickly to drive to those customer results that are needed. So,
a wise man once told me that perfection is not achieved by adding more. It's finally achieved by taking things away. Can you talk about how this concept of subtraction benefits the crews, the timelines, and teams in building these plants out? Like, how is the Nextpower platform not only taking away this over complexity, but also taking away real pain points in the field as a result?
It's not necessarily about taking away complexity, Nico. It's about internalizing that complexity to Nextpower and making it our complexity and not our customer's complexity. And our classic example is our torque tubes. This is not about the integration, but like just to bear into the ethos here of how Nextracker operates for our customers, is we drill holes in our torque tubes to locate our rails for our modules. And that's a very complex operation. It requires an extreme amount of quality and tolerance on the fabrication side. Whereas some competitors might have no drilled holes. Their tubes are easier to manufacture, but they require their customers to use a jig to space out the rails. Whereas we just tell our customers, put the rail in the hole and it will work, right? That's a more complex product. It's a simpler process for our customers. And so when I think about like our foundations integration here, where by integrating the tracker and the foundations, we've managed to increase the installation velocity and reduce the number of part counts. Well, how did we do that? We did that by developing a set of machinery that's automated and does all of the precision of setting the foundation right where it needs to be so that customers don't have to go in and adjust it. It's a very complex machine. It's a very innovative machine. It's extremely complex, but it's internalized to Nextracker. We're taking that burden off of our customers and helping them have a simpler solution in the field, right? And if you can build that complexity in an engineering office and make it not so complex and in the middle of nowhere where you have limited resources and limited time and you're up against your interconnection schedule, that's a total victory for the customer. That's what we're about. By developing a better technology with more complex engineering, you can deliver real simplicity to the customer by completely eliminating construction step.
That same mindset, taking on complexity so customers don't have to, shows up again in the electrical system. And that's where Ryan comes in. Ryan Schofield is the VP and GM of the electrical eBOS and power conversion at Nextpower. Ryan, welcome.
Thank you, Nico. Pleasure to be here.
Ryan, what becomes possible when the electrical system is designed with the structural system from day one? Where do the biggest reliability or even cost wins show up for your owners and EPCs?
Trackers are the backbone of a solar project. So it's where every project starts with its initial layout design. If you think about the way that a project is designed, you get a plot of land and you take all these different trackers and you start laying them out. That's where your design first start. So for an eBOS manufacturer, it's a little bit different. Typically, eBOS guys get all the details later in the game. So you typically get handed over a set, right, that's at a 30 or 60% design set, and everything's already laid out, and then it gets handed to an eBOS guy and says, hey, start designing my electrical set around this. So if you think about being able to start the design of a project from the early stages, you start to understand how many tracker rows are actually in a project. So a typical tracker row might be, this is just an example, but say 200 feet long. So as you're starting to do that layout, you can start adding up how many tracker rows are put across the project. So if you have 1,000 tracker rows and 200 feet worth of cable, you have 200,000 feet worth of cable. So what it allows you to start doing is getting a head start on long lead time materials like cable. We all know copper is a very unstable commodity at times. So if you can start getting a head start on, hey, what does this really look like? What are we going to be doing? You can start having those early level of details. To kind of go a little bit further too, all of these trackers are designed based on the module type. So again, what does it start telling an eBOS supplier? Well, you know your module type, so you start getting an idea of what size fusing you could potentially use, what the connector types are going to be at the ends of your harnessing, which is where one of the biggest problems is. Derek Chase, I think you've had on here before, from robotics, what NX Ranger and Onsite has been able to find out over all these years in inspections is that 80% of the failures on DC health in a project is at the connection point. So it's mismating connectors, its connectors are not seated with each other. And typically those can have a lot of long lead times that are with them, and you kind of get in these really touchy situations. So where I'm going with that is having that early visibility into details like this is you have your tracker, you have your module, now you know your cable, now you know your connector type, now you have your fuse types, is that you can start putting those designs together at a really early stage and start working on the optimization of your DC collection. And what that means is just smoother execution down the road, and you can start seeing where pain points might potentially exist and not exist on a project.
Speaking of pain points, our developers often think in terms of risk and predictability, and design is centered around lowering risk, increasing predictability. EPCs think about repeatability and labor efficiency. How does this integrated approach, pulling in eBOS and the entire electrical system, help each of these actors?
So kind of going back to that, what we see in harnessing designs is, I want to go back to the trackers for a minute too, right? All those different lengths. A lot of times when you're getting that detailed differently, you're executing contracts for different scopes at different periods. So you're ordering the tracker. Owners are typically controlling the module procurement. So EPCs are being told, hey, you're going to use module X on this project. This is what we needed to design around. Here's all the design parameters. So we're able to, again, early on stages get that. And when you can sequence up your designs and you know your wiring distances and you know the way that you're going to go about things, it solves and eliminates things like jumpers that you need on projects, which is kind of always the Band-Aid to solar projects, has always been, hey, harnesses are a little too short, let's introduce a jumper. Go back to the connectors from an earlier comment. The second you start introducing more jumpers, you start introducing failure points to a project. And that's always concerning because failures are 80% of the connector things. So you're adding in jumpers to make things kind of piece together. And it's just piecing it together in bits and pieces. So as you start just Band-Aiding everything, you think about the long-term reliability of a project, that's a pretty risky thing to do. I've always looked at eBOS kind of as the cardiovascular system of a PV plant. So I kind of take the human body as, call it our architecture, right? So you have your trackers as your backbone. Your harnessing is like the veins. Your combiner boxes or load break disconnects are like an artery. And then your power conversion unit is like a heart. So the last thing that you want to do is have unstable veins. You need to have clear arteries that are working for you. And if you're constantly getting chunks and breaks throughout the whole process, you can see how it potentially over time could be not a very stable system. So if we're able to address that in early periods of this, you can start working out all that and then kind of ensuring to the EPC and the developer who's owning and operating a project for, 20, 30 years, that what you're deploying out there it was designed from the original project origination from the get-go. So you know all the details, everything was kind of designed to sync together, and you can start being a real partner to your customers.
Ryan, you described quite eloquently, in my opinion, the electrical side of the power plant as the lifeblood of the system. The eBOS is the cardiovascular system. The tracker is the backbone. The power conversion unit as the heart. When you design all of that in as one system, how does it strengthen the plant's long-term reliability? Thinking from a customer's perspective, a lot of folks are simply trying to simplify their procurement process and their constructability of the plant so that we deliver the one thing people are buying, which are electrons.
I mean, I think it takes a lot of the guesswork out. When you look at the way that an EPC is, structured, typically, you have people that are experts in their space. So you have inverter experts, you have eBOS experts, you have tracker experts, and they're focused on their scopes. Where we're able to step in as Nextpower is say, let us help you do all this so you can take that guesswork out. Example is having the module visibility. That helps pull in the developer saying, we're going to know those connection points and we're going to know where all the connections are. So we're not going to rely on the person who's procuring the module to make sure that the communication is going back to the eBOS supplier to ensure that connection is going to be there.
Right.
We're already privy to that information. So we know this is the module, this is the connector. As we're designing the harnesses, we already know that those two need to match. We're not relying on an EOR or someone from the outside to look at that and say, this connector doesn't match with that connector. Go back and change your design. Go back and change your project. What are your voltage drops? What are all of the technical requirements you need to do to design it? It kind of goes back to just having all of the detail from step one and allowing us to help you design things instead of just giving you bits and pieces and piecing it all together and hoping that it works, and then expecting people who may not have the expertise in one area to connect the dots. While they're probably skilled enough to do that, it's kind of my belief is that if we're going to look at power conversion and electrical systems all together, we'll do the whole thing for you. We'll look at everything. We'll check all the boxes. We'll make it easy. We'll make it smooth. And we'll make sure that those projects are being done on time, which is always the most crucial thing to anything, right? EPCs and owners and everyone is always working toward a budget. And there's always a deadline that goes to it. So our goal is to make sure the project gets done on time and at the budgeted number that it was originally estimated off of, not surprises in the later stages that owners are kind of always getting that toward the end of the project. Oh, hey, by the way, here's another change order. That just means added costs, added labor, fixes in the field, and you're rushing to get to the completion date so you can meet substantial completions, you can have payments go, and you can start producing energy. We can solve all that at the early stages, which ultimately leads to a more higher performing plant.
Ryan, what's a singular advantage that Nextpower gives the market today that simply didn't exist before?
The holistic approach to powering a power plant, integrating in different business lines and different technologies, like our software group, like robotics, and the trackers and the eBOS. I mean, I think that that's one thing that the market has been missing, kind of like I touched on earlier. There's a lot of just, call it component procurement that's going on, that's just patching a plant together. And that's what's really exciting about what Nextpower is doing, is we're taking everything and buttoning it up together and handing it over to someone and saying, this is what your power plant's going to be, even potentially at a block level. This is what your power plant looks like at a block level to help you take it to the next step. And that hasn't existed. It's become just bidding commodities down to a price point, saying, here's my overall target. I need to make sure that eBOS is X amount price per watt. While that's great, and you start chasing numbers, where you start missing the differences is that actually going to work long term, and what's the long term cost of the project? You know, not looking at this from a 1 to 2 year time frame to just hit a budget. It's overall cost of ownership on a project, and I think that's what we do differently, and we're going to be doing differently. That gives it to put power to the grid quickly and more reliably. And then going back to thinking about what the field teams have to deal with. You know, you have all these projects that are accelerating. You have, you know, hundreds of megawatts and gigawatts that need to be installed. And that means thousands of site labor that needs to go out there. The electricity can be a scary thing, right? 1,500 volts of power, you know, 400 amps, 500 amps of all this juice. You have people installing this every day. So we can take that back and look and say, how do we optimize this by saying, this module type typically does X, or it performs like the way that we normally see it. We can use robotics to take all the data that they're doing on their scans and find out in this type of a region with this type of a tracker technology and this module type, here's what you don't do with wire management, and here's what you can do with wire management. Here's how you might want to design the eBOS in differently. So we're using data that we're getting in real time to make educated decisions to ensure that the plant's going to operate more effectively.
You know, we've talked about the physical layers, the steel and copper, and Ryan did a pretty excellent job of giving us a visual of the backbone, the heartbeat, the blood. But the next frontier of reliability, optimization, performance isn't physical at all. It's digital. Next, let's talk about the neural network that brings it all together. I wanted to bring in the person who is connecting those layers into one intelligent system. Jyoti Jain is the head of software product management at Nextpower. Jyoti, thank you for joining us.
Thank you, Nico. Pleasure to be here.
Jyoti, NX1 serves as that digital backbone of the entire platform, tying together the structural, electrical, and operational data. How does that unified layer change the way that owners think about performance, reliability, and control?
I think that layer is really, really important, Nico, to our overall vision of bringing all of these different elements together to behave like a single system. And as you know, Nextpower is evolving, as you've seen, with a lot of acquisitions and putting all of these solutions together for our customer. Annex 1 is such an important part of that strategy because without that, right, it's very hard to create a single system out of these components. So our goal with Annex 1 is to put the system together throughout the product lifecycle, meaning as we design these power plants, we have to put all of these products together and components into a single system. So from design phase to shipping, deployment, and operational phase, we have to make sure these behave like a single system. NX1 is designed to do just that. It has to integrate everything together into a cohesive solution. And that is not just because, yes, we have all of these components, but because that's the only way to realize the synergies that will come with putting all of this under the same umbrella. And the benefits of that synergy, that is what our customers will benefit from too.
Where are customers seeing the clearest benefit from the design all the way through to O&M and uptime?
Well, our customers are seeing the benefits all through and through, right from design to deployment to managing the uptime. For design, let me give you a very recent example. We got really good at designing trackers. We've been in this business for a long time, right? We have very strong design teams. They know how to put it together so that these systems perform and can maintain low cost, which solar industry demands. Now, as we are adding more products to our portfolio, we have the responsibility to continue to design in a way that it still provides the lowest cost to our customers, but also the system needs to perform for decades. In the design system, we are developing in-house advanced design software. And in that, we are considering all of these components as parts of a single system. And sometimes in design, there are trade-offs, right? So as a recent example, we designed a project using our software, and we used the analysis of the ground, the civil works analysis it's called, for the project. We used that to design the foundation system, the amount of steel that goes in the ground, and we optimized that and then calculated the tracker design on top of that so that it all worked together and brought down the cost of that project by millions of dollars. Now, that kind of software, that's only possible because A, we have all of these products under the same umbrella, and B, we have the expertise and the know-how in this industry that we can actually know exactly what the trade-offs are so that we can bring the benefits of high performance and low cost to our customers. So that's just on the design side. Now, if you come to operations, right? In operations, field technicians, they need good tools. And we have learned through our experience that there are areas that can see a lot of improvement. Commissioning, for example, that's another example that recently we have been innovating. We have a new product called NX Pulse. It's a mobile app. Commissioning, as you know, it is a very important part of putting a plant into production. This is when you turn the lights on for something that you constructed. And the commissioning, while it's important, a big part of commissioning can be very repetitive and labor intensive. So what we did was we created this NX Pulse app that can be used by multiple technicians at the same time. And we brought down the cost of commissioning and we improved the speed of commissioning by over 50%. So how did we do that? We did that because we understood exactly what the pain points are for our customers. We exactly understood how it works in the field, how the schedules are tight, and how do we bring it all, bring more value to our customers with our expertise. So we're constantly innovating in each of these areas so that our overall solution leads to faster development times and more ROI for the investments that our customers are making.
So that's what it looks like, one plant at a time. But the deeper value comes from what these systems learn across hundreds of projects by making use of Nextpower's robotics division.
Robotics is one example that I am really, really excited about. This is an area which kind of brings together a lot of things. It brings together hardware with advanced software with the know-how in the field to really solve some of the long-standing problems in the industry. So now, what does that mean? The NX Ranger product, for example, what it does is it is built to navigate through a solar farm and built to detect issues that would have otherwise been very, very hard to detect with human eye. They have thermal imaging capabilities, and on top of that, we're applying the expertise to train these robots to detect issues such as, bad connectors, module hotspots, issues that you could not have detected earlier. And not just that, we won't just detect it, we can analyze the impact and immediately spur the operators into action. That is a lot of value for our customers, because otherwise, either they will know these issues after it's too late, or they might energize a plant and the connectors might not work. So there's a lot of value in providing these kind of solutions and bringing it to the industry. It's not just the technology now that's viable, it's also that the cost of these technologies is viable. And that's why today, this is the moment where we want to leverage all of this technology and bring it to this industry.
I know from conversations I've had with Derek on the robotics team and others that you are seeing an enormous amount of data across the fleets that you help manage every day. Could you talk about the scale of the intelligence feedback and how that integrates back into the design ethos at Nextpower, how you build the next generation of hardware and software?
The good thing with Nextpower is that not only that we have a lot of data, right? As you may know, we get 500 million data records a day from our fleet across the world. Another most important thing to realize is that this data comes from so many different regions, so many different plants in operating under different conditions, that it's very rich, right? The variability is there for us to learn from very quickly. And that's why we are able to now use that data to build our next set of solutions and put that back into our design process to begin with, and then take it all the way from design to deploy to operations. Now, in the design phase, right, to give you an example, trackers are actually, and I'm learning in the last 2 years in the company, I've learned trackers are not that simple to design. There's so much variation possible in the tracker design itself. I don't know if you know, but there are trillions of combinations possible when you design a tracker system. So for us, AI is a much needed technology to be able to really find the best, most optimal design fast and deliver a strong system to our customers. And that is also, by the way, has to be cost effective. So that data that we have from the performance of all the systems in the past, how these systems have performed, where they may have failed, where they need more strength, over time, the company has iterated the design, identified all the components that needed to be changed, upgraded. And so our tracker designs are obviously very strong and have performed, but that now we are layering with structural, with foundation, with electrical systems like Ryan was talking about, and put it all together in a way that the entire system, it performs well, right? Because we don't want a single point of failure, right? So I think that expertise, that data, putting it all together and under the Nextracker umbrella, where now we can also scale this solution and make sure it works in all different conditions. I think that puts Nextpower in a very unique position.
Developing the software layer is not just about how to integrate the hundreds of millions of data points that are coming in real time now, but also thinking about the next evolution in the software and automation stack that will support this connected power plant. What should owners and developers start preparing for now? You all have just had an analyst day and a customer day, and you've been able to share a lot of the future vision and the future state of what is coming through Nextpower. What can you share with us?
Well, one thing I would say to the owners and developers is that be ready to embrace a lot of new technology. And I am a bit biased because I come from the software world. And as I shared yesterday, I really think that software has the potential to transform the solar industry. And why do I think that? I think software has come to a point where it can be deeply embedded with the hardware, which the solar industry, of course, depends on. So in my mind, I would tell the developers and the asset owners that the time is right, the technology is there, and the solutions are coming. Be ready to embrace it because it's going to be good for everybody. It's going to bring the cost down. It's going to bring the reliability up, and it will let us all scale this clean source of energy to a terawatt scale.
Now, with each layer covered, structure, electrical, and software, I asked each of our guests the same question. What does the future demand from us by 2030?
When I think about 2030, I think about not necessarily what might not be true, but what has to be true in order for us to fulfill this incredible demand and this electricity super cycle that we're seeing right now. If we're going to electrify cars, if we're going to make AI data centers possible at the scale that people are talking about, what do we have to do that? And the answer is we have to make power plants incredibly simple, incredibly straightforward, incredibly fast to build and construct, right? When we look at the rate of build out that China is doing, the US has to catch up. And we're going to catch up through innovating on that power plant and making that power plant a turnkey solution, something that customers receive, install, it works. You set it up, there's no troubleshooting, it's designed to work together and it operates. That's what has to happen. That's the assumption that has to break in order for us to meet our 2030 goals as a nation.
When I first started in this space, it was 2011. I walked into my first company and did not know the first thing about what eBOS was. And again, like I said yesterday, I don't think eBOS even existed as an acronym. You looked at combiner boxes where you needed almost between 16 and 20 combiner boxes per megawatt. We're now down to 4. So I think what's next for us is optimizing it, innovating it, getting it better and better, and doing it at a global scale. That's what's really excited me about, one, joining Nextpower, and what we can do differently is we're able to leverage customers' expertise and knowledge in different regions around the globe and take technologies that exist in North America, take technologies that exist in the Middle East and Australia and Latin America. How do they do things? How do we do it in North America? And how do we drive all that together and take the best of both worlds and really create just an overall optimized, technology platform that we can think differently. We can do it at a global scale and not be too focused on just the North American market, which is what a lot of our competitors do right now, is they're focused on North America only. And we're not looking at what technologies, again, exist in other regions of the world and say, that's a pretty good idea and a problem that we may be seeing in North America, maybe listed to a different standard, maybe designed a little bit differently. But how can we think through this and modify it to be something that's special, to just do it different? And I think that's what's always made people successful, that have been super successful, is not always defaulting back to this is how we've always done it. That may have been how you've always done it, but this is how we're going to do it different. And I think that's what's next in Powering Next. That's what really excites me about where we are and what we're going to be doing.
I'll tell you personally, I was born in a place called Calcutta. And first time when I learned about climate change, my heart sank that places like that could be underwater this century. And sitting here in the Silicon Valley, I was working in a high-tech company and I was thinking, what can I do? How do I contribute to a solution to this problem? I made a conscious decision to move into the renewable energy industry. And to me, the power of Next is in being able to decide the future that we all want and being able to take a step towards it. And it's a very, very personal mission for me because I think I owe it back to where I came from, that I work towards a solution to this.
And finally, Jake, what does powering what's next mean to you personally?
To me personally, I have 2 young kids, 5 and 9. And I think like a lot of parents, that motivates almost everything I do in almost an obsessive way. And what's next for me, for Nextpower, is a future of clean energy powered by technology that I can be proud to tell my kids I helped build that, right? And that future will be bright. It'll be abundant. Energy won't be a restricted resource anymore. And as we know, the more energy is available in the world, the better outcomes are available for the whole planet. And so what's next for me is a greener globe, a cleaner globe with abundant energy. And I'm really looking forward to Nextpower bringing that to the world.
I love conversations like this because they remind us of something very simple. Every day, people like you are building the biggest machine humanity has ever attempted, our clean energy system. And sure, it's messy, it's complicated, and it's changing fast. But the people you heard today spend their time solving those problems at scale, and the lessons they shared are the same ones shaping the future of how we actually build power plants. My hope is that you walk away with at least one idea you can use. Maybe it's a smarter way to think about risk, or commissioning, or data, or how all of it fits together. Because when you understand the system, you can build it better. I'm Nico Johnson, and this is SunCast. See you next time, where we keep breaking down big ideas in a way that actually helps you build our future and your legacy. Thanks again for showing up, Solo Warrior. It's half the battle.